everyone, my name is Pamela David, and today I'm going to present my course project for Application Development and Emerging Technologies. For this project, the topic selected is Group 3, covering three interconnected topics in application development: the data store, the platform, and the application, part 1 and 2. I'll briefly explain what the project is about, how I created it, and some of the important things I learned while working on it. To start with, I use a PowerPoint as my tool for presenting. Every application rests on three questions. Whenever you open a food delivery app, a hospital portal, or an online shop, three things are working together behind the scenes. Somewhere your data is being kept, something is hosting and running the software, and the application itself is what you actually see and use. This presentation walks through all three with real-world examples for each. The first one is data store, the platform, and the application. Now let's discuss the data store, where application keeps everything it needs to remember. What is a data store? A data store is any system an application uses to save, organize, and retrieve information so it isn't lost when the program closes. Every time you close an app, reopen it later, and your data is still there. The data store made that possible. It matters because it keeps your information persistent between sessions and devices, lets many users read and write data at the same time, determines how fast an app can search, filter, and update information. So the types of data stores are relational. It stores data in structured tables with defined relationships. It's best for orderly, rule-bound data like accounts or transactions. The non-relational stores flexible, document, or key-based data that doesn't need a fixed structure, scales easily for fast-changing apps. The file object storage. It holds whole files as objects, images, videos, PDFs, rather than structured records. Examples are Amazon S3 and Google Drive. And in-memory storage keeps data in RAM for near instant access, usually temporary. It's great for caching and live sessions, such as browser, local storage, or Redis. So examples in practice: an online shop. Take an e-commerce store similar to the kind used for small business inventory and order management. It doesn't rely on just one data store. It usually combines several, each doing the job it's best at. So that is the product catalog and orders, and that is the relational database, the product photos, the object storage, the live shopping cart, in-memory store, and the customer chat reviews, which is NoSQL database. The next one is the platform, the environment an application is built for and the ground it runs on. So what is platform? A platform is the underlying environment, hardware, operating system, or cloud service that an application is built for and runs on top of. It determines what tools a developer can use, and what device the end user needs. The first one is web platform. It runs inside a browser or any device. It doesn't need to be installed. The examples are Chrome, Safari, and Edge. Second is a mobile platform built for phones, operating system, and App Store. The examples are Android and iOS. Desktop platform is installed software built for one operating system. Examples are Windows, Mac OS, and Linux. The cloud platform hosts and runs the application's backend for you. Examples are AWS, Azure, and Google Clouds. Example in practice: one app, many platforms. A single business, for example, a telehealth or booking service, often reaches users across more than one platform at once, while the backend runs on a cloud platform behind all of them. So the web app, the mobile app, and the admin desktop tool, uh, all in one in the cloud platform as the host the backend. The third topic is the application. There are types of application and how they are structured. The common application types are web application. It runs in a browser and doesn't need to be installed. Mobile application installed from App Store, built for one OS. Desktop application installed on a computer operating system. It is a hybrid and the hybrid and cross-platform. One code base runs on web, mobile, and desktop. The client server architecture here shows the client, the server, and the data store. The client is what the user directly interacts with, and the server holds the application's logic and rules and talks to the data store to save or fetch information tying directly back to topic one. So how an application gets built, the development life cycle. The first is we plan it, we define the problem, the users, and the goals. We design it, the sketch the interface and the data structure. And the third one is develop, right? The front end, back end, and the data layer. And then we test it, we check it for bugs, usability, and performance. The fifth one is we deploy, we release the app on its chosen platform and maintain, update, fix, and improve after launch. Every application from a single booking form to a full hospital system moves through this same cycle. Emerging tools like AI assisted coding and low code platforms are speeding up the develop and test stages, but the cycle itself hasn't changed. So data store, platform, and application are the full stack. So in summary, the key takeaways are the data store is where the application keeps its information. The right type depends on the kind of data. The platform is the environment an application is built for and runs on. The web, mobile, desktop, and cloud, and shapes at both development and reach. The application is what ties it together. It, it, its client server architecture, and the life cycle it goes through from planning to maintenance. These three layers are never really separate. Understanding how they connect is the foundation for building or even just evaluating any modern software system. That's it for my course project. Thank you for watching.